Properties of inverse matrix. First properties. A inverse and inverse again, so equal to A. A transpose, then we made the inverse operations, so it is equal to, if we find the inverse first and then make it a transpose operations. Okay, number 3, A times B, and then we find the inverse for A times B will be equal to B inverse times A inverse. Okay, fourth, the determinant of A inverse is equal to 1 over determinant A. Okay, so for this one, don't be confused with in A inverse equal to 1 over A, because this properties is about the determinant. Okay, before this, what you see is about the matrix. Okay, so if we have A times B equal to BA equal to identity, so meaning that both of these matrices are inverse to each other. Okay, where B is equal to A inverse and A is equal to B inverse. Hence, so if you have this kind of property of results, let's say we have A times B equal to Ki. K is a scalar, any numbers. So then the inverse of A, we can find it by dividing B with K, or 1 over K times B. Same as if you want to find the inverse of B, so divide B with constant K, or 1 over K times A. Okay, so now we will learn about how to find the inverse by using the AB KI properties. So if AB equal to I, where A and B are square matrix, then B is called the inverse of A. Okay, thus this is what you learned just now. By substitute B with A inverse, the result will be identity. So you have to remember this: A inverse times A, or A times A inverse is equal to identity matrix. Okay, let's see example 8. If we have this question, kind of questions. Okay, about application of AB may equal to KI, the expressions. So we should have at least two information. For example, this one we have A and B matrices. Given A and B, it is known that AB equal to Ki. K is a constant, I is 3 by 3 identity matrix. Find K, hence deduce. So now we have the word of deduce. A inverse means that you have to find A inverse by using AB equal to Ki. Cannot use the adjoint method. Okay, let's see the solutions. Okay, this is A times B. By multiplying these two matrices, so by multiplying the row with a column, yes, and then for the second entries, first row, second column, third entry for the with third column. Okay, next for the second column times with first column, second column, third column in order to get the entries of second row. And then for the third row, by multiplying third row with first column, second column, and third column in order to get the third row entries of matrix A times B. Okay, so we can get this is the result. 2 0 0 0 to 0 0 0 2. All the entries are 0 except the diagonal entries, which the diagonal entries we have the same number, that is 2, that we can factorize 2 from that matrices. Okay, so we can get something like this. Therefore 2 times identity, so we have ABKI form. Okay, from there we can get the value of K is equal to 2 by comparing AB equal to I with AB equal to KI. Hence, in order to find the inverse, we have to use this result. We can use the adjoint method in order to find inverse by using these properties, by multiplying A inverse both sides, because we want to find we want to find the A inverse. Is that we have to multiply A inverse both sides. You have to be careful the location of A inverse, whether on the left or on the right of A. So if A is on the left as this one, means that A inverse should be on the left side of A. Okay, so same as this one for the right hand sided, so it should be follow left hand sided, also on the left of 2I. Okay, A inverse times A is identity. A inverse times I is A. Okay, so therefore by leaving A inverse the only term on the right sided, moving these two on the left hand, so we have the A inverse is equal to 1 over 2 times B, and then substitute B with matrix B from the questions, and then simplify the inverse. Then just leave it like this. Okay, so we have 1 over 2, 1 over 2, negative 1 over 2, and then we have negative 5, we have 2 and 1, 7 over 2, negative 3 over 2, and negative 1 over 2. So this is our inverse. Example 9. Okay, given A. Okay, this is the first conditions. Find the value m and n such that a square plus ma plus noi equal to 0. This is the second information. Okay, find, obtain A inverse and show that A cube equal to 9A minus 7pi. Okay, A inverse A square plus ma plus ni equal to 0. In matrix, we don't have any square operation. So if you found something like this, means that this one is A times A. Matrix A times matrix A, not square. Okay. Okay, matrix A times matrix A plus M, matrix A plus N, matrix identity equals to matrix 0. Okay, by multiplying this A times A, so we can get this one 11 7 7 and so on, plus m. Okay, just put it down all of this. Okay, after that, by comparing summation for the same position in order to find 0 mn, so we can choose any entries that we like. We have 9 entries here, so just choose 2. Okay, in order to make it easier, choose second entries or third entries. You can choose the same. So we have, for example, you have this one plus m times 1 plus n times 0. So we have 0 for n. That's why we don't have n here, equals to 0. Okay, so therefore we can get the value of m, that is negative 7. And then in order to find n, so we need n, so we n is come from this side, so we can choose diagonal, and we can choose non-diagonal entries. So we have to choose diagonal entries because we need n. So we can take this one, for example, okay, 3 3. So 11 plus m times 3 plus n times 1 equals to 0. So therefore we have the second equation. Then by substitute m into this one, so we can get n equal to 10. Okay, so second questions. Now we have a complete statement. A square minus 7a plus 10i equal to 0. So we want to find the inverse. So it means that we can, by multiplying both sides with a inverse, so we can get, okay, this statement, all of this. A inverse times a square, so we have a identity, because this one we have a times a times a inverse, so these two become identity. Okay, this one according to the properties that we have before this, also a times a inverse is identity. Identity times a inverse is equal to a. Identity, the concept of identity is equal to 1. 1 times anything become that numbers. So similar as identity in a matrix. So we have this one, a times identity become a. Okay, a identity, a times identity become a. 7 times identity is equal to 7 identity, not 7, because this is the matrix, not 1. So we still have to write this identity because this one is a matrix. Okay, now we want to find the inverse, and next step, just leave it a inverse on the left hand side, and then 10 we have to move to the other side. Okay, this is the inverse expression. Okay, question B. Okay, we have to show a cube equal to 39a minus 70i. So a cube is equal to a square times a. So from the statement that we have before this, here we have the statement of a square minus 7a plus 10i equals to 0. So from this we can get a square equals to 7a minus 10i. Then we need to substitute this a square with this expression, so we can get Okay, this one 7a minus ni times a, and then we can expand these expressions become something like this. Okay, now we have a square again. Okay, the statement that we have to show, we don't have any term of a square, so we have to substitute a square again with this statement. So therefore we have this thing, and then we need to expand once again and simplify. So we have we have the answer that we need to show. Yes, okay, conclusions. Adjoint formula of inverse by using adjoint method. Okay, this exercise.